Today we're going to start our presentation by saying that our student of the day is Danielle because it's her birthday. Happy birthday, Danielle. So up until this point, we have graphed parabolas just by using the standard form, by using the DV, direction, axis of symmetry, vertex, and y-intercepts. And today we're going to learn how to graph parabolas from vertex form. So if the equation's in vertex form, it's pretty easy to find what the graph of the parabola looks like. So you've already written down this, hopefully, in your notes on a previous presentation, so you don't have to write it down again. But I just wanted to quickly refresh your memory about how just general graphical transformations work. So if you add a number to the outside of the function, that shifts that whole equation, the whole graph up, C units. If you subtract C, then it shifts it down C units. If I add or subtract C on the inside of the function, meaning that I just do that adding and subtracting just to the x, then it shifts the graph right or left, kind of in the opposite way that you would expect. If you add C, it shifts the graph to the left, and if you subtract C, it shifts it to the right. And if I multiply a number on the outside of the function, that gives a vertical stretch to the graph, or vertical compression. So here, if the number is bigger than 1, it's a vertical stretch, meaning that makes the graph skinnier. If the number is between 0 and 1, then it's a vertical compression, meaning that it makes the graph wider or fatter. If I have a negative multiplier on the outside of my function, all that does is flip it upside down. Or flip it. So here's where we should start writing stuff down. This is vertex form of a parabola. If you recall, we did a little bit with this when we were in the computer lab, how the graph changes when you change the value of A, what happens when you change the value of H and K. So hopefully you remember that if you change the A, you just made the graph wider or skinnier. So the A really affects the vertical stretching of the graph, just like we talked about in the previous slide. And the H is just the x value of the vertex. So if you remember when you changed the H when we were doing that computer lab, the whole parabola moved either left or to the right. The whole thing just shifted. And that K is just the y value of the vertex, meaning that it affects how high or low the parabola sits on the graph. So this is very convenient when you have it in this form because you can just look at the equation and tell what the vertex is. You don't have to do any calculations or any negative b over 2a or any of that. You can just literally see what the vertex is. So here the vertex is just hk. So when you have a regular equation with numbers filled in, you can just look at what those numbers are and plot that on your graph, and you know that that's either the top or the bottom of your u. So when you're graphing from vertex form, these are the 4 things that you should do. The first thing is to identify the vertex, which should be very easy. It's just H, K. The next thing is to identify the direction. If the A is positive, it goes up. If the A is negative, it goes down. Same thing. And identify any vertical stretch. So if the A is a number bigger than 1, then the parabola will get skinnier. If it's a number between 0 and 1, for example, 1/2 or 1/3 or 2/5, then it'll get fatter. The parabola will get fatter. And then the only other thing you have to do is plug in one other point in for x and get 1 point. So you have a guide for how to draw how wide or fat or skinny to draw your u. So let's do an example, a couple of examples. So the first thing that we were going to do is identify the vertex. So if you look here, remember that these are of the form a times x minus h squared plus k. So here, if you can tell, the h is 1 and the 2 is a k. So our vertex is 1, 2. So I know that that will be where the top or bottom of my u is. Now let's look at the direction. Because here there's no number in front of the parentheses, it's just all the 1 is what a is. So that means that my parabola is going to be going up. And there's no vertical stretch, so it will have just the normal width. And then the last thing we have to do is just plug in any other point. You can plug in any point that you want. Sometimes I like to plug in It doesn't matter. Let's plug in 1. I'm sorry, 1's not going to work. Let's plug in 0. If I plug in 0 into this equation, then I get 0 minus 1 squared will be negative 1 squared, which is just 1, plus 2 is 3. So that will give me the y-intercept because I chose to plug in 0. So I have 0.03. Now, you know that this is the middle of your parabola because that's where the vertex is. So you can reflect that point over. That will give you a guide for exactly how wide to draw your U. Now, the next one, here, the first thing I want to do is identify my vertex. So, my h is this number. But if you notice in this formula, the h, it's x minus h. So here, my h is not 3. My h is negative 3. And then the same thing with my k here. My k is not just 9/2, it's negative 9/2. So 9/2 is a fraction. I know you guys freak out when there's a fraction of problems. But just do 9/2. What's 9 divided by 2? 4 1/2. That's just negative 4.5. If it helps you think about it as a decimal, that's fine. I don't care whether you write it as a fraction or a decimal. So now you should be going to the point negative 3, negative 4 1/2. 1, 2, 3, 4, and a little bit. So that's going to be our vertex. So now let's decide on the direction. Because there's a negative here, my direction will be down. My parabola is going to be an upside down U. Then let's talk about the vertical stretch. There's no number here, it's just negative 1, so we'll have the same width that you would expect for a parabola. And then the last thing is to plug in any other point. Plug in whatever you want, it really doesn't matter. Let's plug in negative 1. I wanted to pick something that wasn't too far from the vertex. If you picked a number like 5, you would end up getting a number that was difficult to graph. So if I plug in negative 1, I end up with negative 1 plus 3, which is 2, squared, 4. Then I have this negative on the outside, so it's negative 4 minus 4.5, that's the 9/2. That's negative 9.5. So I'm going to then graph the point negative 1, negative 9.5. So it's all the way down there. Now you know that this is your axis of symmetry, so you should reflect this point over that line to give you a nice guide to draw your parabola. Isn't that just beautiful? Alright, so now let's do our joke of the day. So our joke of the day is that 2 students were talking about school together, and one student said, our teacher always talks to herself, does yours? And the other kid said, yes, but she doesn't realize that she thinks we're actually listening. Right, like that. So now let's try to graph these parabolas. So here are just 2 examples where it's not shifted in 2 directions, only one. And we have an A that is of consequence. So the first thing we want to do is identify the vertex, just like before. So remember that our general form of a parabola is A times x minus h squared plus k. That's just vertex form. So here, hopefully you can see that the h is 4, but there's nothing added on here. If there's nothing added on, then our k is 0. So the vertex of my parabola is 4, 0, right there. Now let's look at the direction. Here this parabola is facing upward because the a is positive, and because we have a 2 multiplied in front, I have a vertical stretch of 2. So this should let you know that my parabola is going to be skinnier than normal. Now I'm just going to plug in one other point. Plug in whatever you want. I'm going to plug in, I don't know, 2. So if I plug in the point 2, then I get 2 minus 4 is negative 2. Squared is positive 4 times 2 is 8. So now I have the point 2. 1, 2, 3, 4, 5, 6, 7, 8. And I know that my vertex is on the axis of symmetry, so you can just reflect that point over like we did before, and then you can draw your pretty little U, and it's a little skinnier than expected. So now let's do this one. So here let's try to find the vertex. So here there's nothing subtracted from the x in parentheses, so that should let you know that the h here is 0. And now let's look at the 4 here. That 4 is our k. So it's Now we are on our vertex is 0, 4. Let's look at the direction here. Because this A is negative, my parabola will be facing downward. And because it's multiplied by 2/3, I have a vertical compression, because it's a fraction that's less than 1, of 2/3. Meaning that my parabola is going to be wider than usual. Now I'm going to plug in just any point that you want. I'm going to plug in a number that is divisible by 3 so that I don't have any fractions when I end up getting what the point is. So I'm going to plug 3 in. If I plug 3 into this, I get 3 squared is 9. Negative 2/3 times 9 is negative 6. Plus 4 is negative 2. So I have the point 3, 1, 2, 3, negative 2. I also have that same point on the other side. You should reflect it over your axis of symmetry, which in this example is just the y-axis. Graph our parabola. So it's not much wider than normal because negative 2/3 is close to negative 1. So don't forget to answer the questions, and I'll see you guys soon.